We are unit circle, I believe, correct? All right. So, we will do a review of last year first. You will not get it for any of the test days. They provide you a blank copy of it, and you need to fill it in. And basically, when we get to the exam, that's exactly what I tell you to do: is fill in the first section, the first quadrant of the triangle, or of the half circle, quarter circle, I guess, so that you can have it beside you. And then after that, filling it in is just the same values all the way around the circle, if you remember correctly. Okay, so the first part of today is when we did the unit circle, we did it all with degrees. Okay, and we did it with the 30, 60, 90 triangle and the 45, 45, 90 triangle. All right, so you remember that part of it? All we're going to do right now is we're going to show you how to change it into radian measure. All right, so again, it was called the unit circle because the radius was 1, right? So this coordinate here was 1 and 0, 0, 1, negative 1, 0, right? And 0, negative 1. Okay? So then we started with this guy right here, which was the 30, 60, 90, which was 30 degrees. And we found out what the sine and cos were for it. So to review, we're going to, oops. Okay, we're just going to do the first one for right now. And the number one thing that you have to remember is the sine of 30 degrees, which is what? What is it? It's a half. Okay? So if it's a half, what's the other guy? Guys remember? So everything starts, and this is in 4.2, so we're going to get to that. But I want to review. So if 30 is a half, what does that make this side right here?
Three.
Pardon me?
Nothing.
You said it. What is it? Pardon me?
3.
Not 3.
Root 3.
Root 3. That's right. That's root 3 right there. Right? Because this squared, subtract that squared is equal to that squared because Pythagoras' theorem. So 4 subtract 1 is 3, square root of 3. So we leave it as that. So what's the cos of 30 degrees then? What's the side adjacent to the angle? Thank you. So 3 over 2. Okay? And then 60, how does 60 change? What's the sine of 60? And what's the cos of 60? So how did that change? Exactly. Your x and y switch. Okay, so we gotta go back through all of that by the looks of it. All right, but today, the 4.1 is all about this. How many degrees do we go around the circle?
360.
360. Now, if I asked you what the circumference of the circle is, what would be the circumference?
2
pi.
2 pi. How come 2 pi? How do you find the circumference of a circle? 2 pi r. And what's the radius of this circle? Its radius is 1, so it's 2 pi. So when we refer to this, that is the actual distance of the arc length around the circle. Okay? How many degrees is it around the circle? 360. So, in other words, if I go all the way around the circle, That's a distance of 2 pi, or 360 degrees. You would agree with me? So what would be halfway around that circle?
Just pi.
Just pi, and how many degrees?
180.
180. This is the conversion I use to change degrees into radian measure. So again, radian's measuring the pieces of the circle in terms of their distance, all right? But we refer to it as pi radians, in which radians is another way in which we're describing an angle. Now my best analogy for this is miles and kilometers. They measure the same thing, correct? And you have a conversion for them. There's so many kilometers in a mile, right? Well, there's so many radians in degrees and so many degrees in radians. You follow this so far? Okay, so I have pi radians over 180 degrees. So then, if I looked at 30 degrees, and I wanted to find out what portion of the circle is it, I times it by pi over 180 degrees. 30 goes into 180 6 times. 30 degrees is pi over 6 radians. Okay? What would 90 degrees be?
Pi over 2.
That's right. So do the same thing, pi over 180 degrees. Pi over 2 radians. Right? So now, we would go around the circle, and we would label them. So this is pi over 6. Right? You don't need to put this in. We're going to go through this in its completion in a minute. So pi over 6. What's another 30 degrees then? How many radians would I add on to that? Well, what's 130 degrees?
Pi over 6.
So then add another 30 degrees. What does that
Pi
give
over
me?
6. So 2 pi over 12.
2 pi over
6.
6. Right?
Sorry.
No, that's fine. Yeah.
Column.
Here, we go back into fractions now. Everybody's going to hate this. Right? So 2 pi over 6, which is 60 degrees. So 60 degrees, I reduce that, it's pi over 3. Okay? So you can go around the circle, and this is what we'll do next. We'll go around that circle, and we'll go by pi over 6, pi over 6, pi over 6, pi over 6, all the way around. So it'd be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, all the way around for the 30 degrees, and then just reduce the fractions after that. Okay? So you don't have to actually memorize all of the different radian measures. All you need to do is remember that pi over 6 is 30 degrees. So you can find out how many pi over 6s there are to that point. Now, there was one other triangle we looked at. And without explaining all of it, again, this is into 4.2, but I'm going to fire it all together. Without explaining all of it, okay, I'm just going to do this. So what's the sine of 45 degrees?
2.
Pardon me?
2.
Root 2 over 2. What's the cos of 45 degrees?
2.
2 over 2.
Also root 2 over 2. And what is the tan of 45 degrees?
2 over root 2.
Over
Root 2.
over 2, which is 1. So in this case, right? Oh, sorry. It's root 2 over root 2, right? Which is 1. Okay. So the one thing we have to remember too, I'll bring this all back up so it makes sense. So you're going to understand why we spent so much time on it last year, because this will come back to you. The tan of any angle can be found by taking sine theta over cos theta as well. I need you to remember that. Okay, so that's part of it. Okay, so far, we're remembering some of this. It all comes from these two triangles. Everything you're going to do for the next 3 units comes from these two triangles. We have to know those values inside and out. Now, when I say an exact value, what is the exact value of the sine of 150, let's say? So that is over here. When I say an exact value, there is zero calculator work here. You need to remember what the sine of 150 is. And if you recall, which you probably don't, it all happens with your reference angle. So I made another 30, 60, 90 triangle. So this guy has the same exact values as this with one glaring difference. What is it? One's a negative. So this becomes negative root 3 over 2 and a half. So what's the sine of 150 degrees then? What's the exact value of it? What part of that is, yeah, it's a half. And what's the cos of 150? Negative root 3 over 2. So you're going to, your end game, there's two things that you're going to end up doing. The first one is to get these all down pat. The 30, 60, 90, the 45, 45, 90 triangles. Get all of the values around it locked in. Once you have that locked in, you're going to figure out another way of finding the exact values for different angles, such as the sine of 15 degrees. So there's a whole method in order to find it for angles that are related, but not on the unit circle. That's your end game. Your end game is, how do I find out what the exact value of sine 15 degrees is? So that means you're not going to use your calculator. You're going to have some sort of square root over a square root, or a square root over a value in terms of a fraction. That's where we want to get to. Okay? And you have to nail this guy first. All right? So what I'm going to do right now, I'm just going to pull up the grade 11 one. Lovely. Okay. So let's have a look at this now. So this is your 30, your 60, all right, going all the way around the circle. Okay? So again, this guy right here, this angle, that's referred to as your reference angle. So your reference angle is always made with the x-axis. So your coordinates, these guys, are all solely dependent on the reference angle from the first quadrant. Okay? I'll give you a copy of this. I just want you to look at this right now. All right? Get it squared away. Okay? So, what am I missing on this right now that you see?
The 90.
The 45s, right? So we'll add those in a second here. But what I want you to do is I want you to look at this first. The thing that we add on to this from grade 11 to grade 12 is now we have to add that onto it. We add on pi over 6 radians. Okay? So it's the exact same thing that you did last year, plus radian measure. All right, so let's count this around the circle, and let's do this. 1 pi over 6, 2 pi over 6, pi over 3. 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. Nope. Yeah,
No, that's
I missed,
10.
this one's 10 pi over 6 right here, right?
Well, then did we mess the other ones up too?
No. No, I think we're okay. 8, 9, this is 270 here in the bottom here. This line is 300, so I just wrote it fine. So this is 5 pi over 3. Okay, and then finally, 1 pi over 6. So it's not that difficult. As long as you remember the 30 degrees. So if you don't remember that, then times it by pi over 180 and understand that it's pi over 6. So then we go all the way around the circle, right? And count them. You don't have to remember that they're pi over 3s. Just remember to reduce them after. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, 6 pi, or 12 pi over 6. We also have to remember that one, which I didn't put in, which is 2 pi. Okay? And then you could keep going. Remember, we don't stop. That would be the difference in grade 11 and 12 as well. Grade 11, you only talk about things in specifics to 0 to 360, or 0 to 2 pi. You guys may have to go around more than once, more than twice, just to remember it, or you may have to go in reverse order, which is negatives. Negative 1 pi over 6, negative 2 pi over 6, negative 3. So those are the things that are different. Okay? So right now, these are the things that we wanna be able to do. Let's add in the 45s right now, so that we have the 45s, the angles in degrees, angles in radians, and the exact values. Okay? So we add that in. Alright? So now that's 45 degrees, right? Which is pi over 4. Okay? And then root 2 over 2 and root 2 over 2. So far so good? 1 pi over 4. 2 pi over 4, which is pi over 2. 3 pi over 4. So I've got 135 degrees, 3 pi over 4, and negative root 2 over 2, and root 2 over 2. Right? Okay, down here. So there's 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, right? So that is 225. 5 pi over 4. 6 pi over 4. And that's what, 315? 7 pi over 4. And exactly. Okay? It's basically a pattern. Is essentially what it is. Alright? Grade 11, does anybody have any issues?
I have a question.
I'll help you. Okay. Alright, so let's look at page 110. Let's go through, write this out in your book, and then we'll come back to this. Okay? So, 110. Alright. Draw each angle in standard position, convert each degree measure to radian and radian to degree. So 135. To draw it out, right there, right? What is the reference angle for 135 degrees? 45. So what does that measure as a radian? Which one though? Okay, so, okay, no, you're, alright, fair enough. I know what you're saying actually. There's 45, right? So what is this angle here though? That's 135. This is pi over 4. What is this one? 3 pi over 4. There you go. Awesome. Okay. 5 pi over 6. Where's 5 pi over 6? 5 pi over 6 is right there, right? What's the reference angle?
30.
Yeah. Okay, but use it in terms of pi's. What's the reference angle here?
Pi over 2.
Awesome. Awesome. Reference angle, pi over 6. Okay. What does that measure in terms of degrees?
150.
150. What's the exact values? So I'm asking you for the coordinates now. When I ask you for exact values, I want the coordinates. So what's the coordinates of that guy? Remember, your reference angle is 30 degrees. So what's the sine value of 30? Right? We'll get into a rhythm here. Okay, now this is the one that throws everybody off. We talk about all the time, we refer to radian measure in terms of pi's. But radian measure, if you understand, pi is just a number, it's a value, right? It's 3.14, with it's an irrational number, so it goes on forever, right? So in theory, 2 pi would be 2 times 3.14 or whatever, it would be 6.2 something. Okay? 4 is a radian measure. It just doesn't have anything to do with pi. So where would it actually be? Well, pi is 3.14, right? So from here to here would be pi, which would be 3.14. 4 would be somewhere down there. It would be greater than pi, but less than 3 pi over 2. Correct? Is that right? What would be 3 pi over 2? An approximation. Think it through. What would be 3 pi over 2?
1.6.
What do you think it is?
1.6.
Why would you say 1.6?
Is it pi over 2, right?
3 pi over 2.
Oh, no.
Okay, so go with it. You're doing the right thing. What's 3 pi over 2? Approximately.
3 pi is like,
Yes?
like 9.
Yes.
Something.
Divide by 2.
Do like 4.5.
Yeah, so this would be approximately 4.5 down here, right? Okay? And I said that this is approximately 3.14, so 4 falls in here somewhere. So to convert it, I go 4 times 180 degrees, and I divide by pi. Now this one, because this one I would use my calculator for. Okay? So I would take 4 times it by 180 and divide it by pi, and I get it. And again, because we're using angles, we need to have three decimal places. What do you get?
229.183.
So 4 radians falls somewhere between pi radians and 3 pi over 2 radians, right? It's a value of 229.183 degrees. Okay? Okay so far? So just because I don't have a pi in there doesn't mean that it's not pi radians. Like it's not a radian value. Okay, it doesn't need a pi value to be a radian measure. Because a pi is just a number. So as long as it's a number, it can be a radian measure. If you do not see the degree symbol, then you have to assume that it is an actual radian measure. And then if they want you to convert it, just times it by 180 over pi. Okay? All right, look at page 112. Identify the angles coterminal with 210 degrees that satisfy the domain. Express the angles coterminal with 210 degrees in a general form. Okay. So, first things first. We agree that this is 210 degrees? Okay. This word here. Coterminal means in the exact same position. Coterminal means in the exact same position. So how do I find another angle that's in exactly the same position? How do I find another angle that's in the exact same position?
Taking that circle.
Well, I need it to be back to here every time. Any idea? You're close. Close. Okay?
Do you go around again?
Yeah. Yeah, I do. So what am I doing? How do I get to the next one?
360.
Yeah, exactly. Okay? So if I add 360 to this, I go right back to there, right? So the next angle that's coterminal with this,
570.
570. There's one that's coterminal. How would I go with the next one less than this? Subtract 360. So that would give me actually a negative value, which would be, subtract 360 from that.
170. Oh, 150.
That's right. Negative 150. And then to get to the next positive one, what do I do? Add 360 again. To get to the next negative one, I would subtract 360. So here's how this works. They asked for it in general form. This is going to become very important to you, how to write this. Not so much in degrees, but how to write it in radian measure. So I can add 360n. Casey, pay attention to this. Write it down. I add 360 degrees n, in which n is an integer. So we have to write that out like that. In which n is an integer. So what that means is n represents the number of times you go around the circle in a positive and a negative way. So plus 1 to the 360. So if this was a 1, that means I go once more times around the circle. 210 plus 360 gave me 570. If n was a negative 1, we got to negative 150. To get to the next one after that, this n becomes twice. And 3 and 4 and 5, and negative 2 and negative 3, negative 4, and 5. Okay? Now we don't need it so much for this in degrees. But we sure have to know this in radian measure. And when we do some other things, we do some graphing, we need to know this, how to write this. So what is 210 degrees in radian measure? Somebody want to guess? Don't use your calculator. Okay? Just think it through. In radian measure. What's the reference angle? So it's got to be a pi over 6, right? Okay? How many pi over 6s does it take me to get to here?
6. Oh, 7.
7 to get to 10.
7 pi over 6. Okay? Now, how do I represent 360 degrees in radian measure? This is hugely important to us because any graphing we do, we have to write this notation out. Have to write that notation out. Okay? So that's that. All right. I've basically given you everything So what I want you to do right now, this very second, is go to page 119. Okay? And I want you to attempt to do this on your own before I give you a copy of it. Okay, so that's your assignment right now. Then you can finish off 4-1 and get started on 4-2. All right? Any questions? Do we remember this? Like it's there somewhat? Yeah, but once you get going, you'll be good to go. Okay. We're working on that thing.
Are we